Reporting for First Updates Now, I'm Abbas. With me here today, I have Team 6165 MSET CuttleFish. They were the Alliance captain of the 4th Alliance here at the Maryland Tech Invitational today. Really excellent performance for them all the way from quals to playoffs. Unfortunate that they lost in the playoffs, but you know, it's a very tough competition.
This video on First Updates Now is made possible by viewers like you and also the following sponsors. Discover MSOE, where hands-on learning today can lead to real-world applications tomorrow, including their We Energy STEM Center built to support first teams. Head on over to msoe.edu/visit to see a virtual tour and schedule your campus visit today. Apply the skills you gained as a first student or mentor and help change the world at Stryker. Stryker is the top career choice for many of those in FIRST because of their commitment to innovation and saving lives. Learn more about the incredible culture at Stryker and view their thousands of positions available around the world at careers.stryker.com.
Ayush, let's start about your robot. So why don't we just start with the drivetrain? You guys have a very unique drivetrain. I've seen your suspension system run match after match. It's just fluid over those barriers. How did you guys get there, right? Like from day one up until now, what's the work that went into that?
Yeah, so we actually started with a completely different robot in our first qualifier. So if we flip the robot over, Matthew, do you want to help out with that? Yeah. So, all right. So you can see here that each wheel module is independently sprung, which allows us to easily traverse the barriers. And when we started off, we like from the get-go, we wanted a 6-wheel, 6-motor drivetrain. But initially, those wheels were pretty much all, I guess, hard locked in. And so this allows us to basically not jump all over the place when we're going over the barriers, which is a requirement with a bot as wide as this.
Yeah, of course. And you mentioned having a wide robot. Is that something that you guys were like, okay, we want to have a wide robot this season, or was it more like, okay, this is just the design is limiting us to have a wide robot?
So I think partially we were pretty inspired by last year's MTI and all the defensive action that we saw, and we kind of wanted to get in on the action. And you know, maybe we still think that defense has its place in this game, and so we tried to show it in some places in our qualifying matches. Unfortunately, I mean, not everything worked as planned, but I still think that in theory, defense with a robot as large as this can be pretty annoying to play against.
Yeah, definitely. I mean, we saw you guys, you guys were pushing around, going into the opposite warehouse, this and that, and I think it definitely impacted teams, maybe just not have been the outcome that you wanted. So yeah, I think you guys have given an excellent overview of your drivetrain. Let's go over to your intake. So you guys have a pretty complex intake. There's a lot of features to it, a lot of things. It's not just a simple, axle with some surgical tubing on it goes into a box. Can you guys talk about that, how it's changed throughout the season, where it is now?
Yeah, so I think our intake has actually been one of the parts that's been most innovative, or is like one of our most innovative parts, because a lot of motors are taken up by other components. In order to have the extension driven, we started off with just simple linkage servos in our previous robot, directly driving the linkage. But what we noticed was if we rammed into something, that it would, I guess, break the servos. Yeah. So with this new design, we actually have a spring-loaded shock absorption, and that basically means that there's 3 servos at the back of our robot. There's 3 servos at the back of our robot that drive a linkage, which has a directly driven bolt and a, I guess, like passively driven compliant spring. And so that part is what pushes it forward. The spring is what pushes it forward, and the bolt is what pushes it back, which means that our retractions are always, I guess, fast, but our extensions might be slightly slower, but we can absorb the shock if we ever hit something.
Sure, that makes a lot of sense. And why did you guys decide to go with an intake that extends? Why not just keep it simple with something that's on the front of the robot and can reach freight still? Yeah,
so having an extending intake was especially important with a robot as wide as this, because if we are in the warehouse, we're taking up a lot of space, and because we primarily play on the Alliance side, it's beneficial to leave some space over here for the shared bot to operate in. And we saw that especially in our first qualifying tournament where we just disabled the extension because the servos were breaking.
Yeah, I mean, we saw you guys playing today. It seemed like you had 2 big robots going in on the field, but they had no issues collecting freight. Both of you guys were just able to get in and out every cycle after cycle. Okay, cool. Now that we've gone over your intake, let's go over to your transfer. How does that work? How does it get into your deposit?
Yeah, so after freight is collected, it's actually our intake is actually coaxially geared, So that means that the surgical tubing stalls against the freight, which means that the motor, the force from the torque from the motor is redirected to rotating the intake box up. And then we initiate a retraction, and then once we have a sensor here. It's just a simple distance sensor, rev distance sensor. Once the intake, hits it, we start to just spit it out the other way.
Yeah, awesome. And let's talk about your deposit. You guys have a very elegant, super fast deposit system, and I'm sure it hasn't been this way the entire season. You guys have gone through a ton of iterations, so let's talk about that a little bit.
Yeah. So I think in our old deposit, or in our very first deposit, was basically nothing like this. It had the linear rails, though they were purely vertical, not angled. And instead of having an arm that would flick, it had kind of like just a tilting
box.
Yeah, a tilting box that would just drop freight directly behind it. And the problem with that was that it wouldn't be able to score towards the back of the hub. So with our next iteration, we added an arm, which would be able to reach towards the back. But then we noticed that, especially with all the defense that went on at NorCal, that if a robot was playing right behind us, we couldn't really do much to get right over it because they were like usually full 18 inches of width or length. So then we added the linkage extensions, which allow us to basically reach over any robot that's within the 18
wow. And I mean, we saw this especially today with Hyperion 9614. You guys were scoring over them, and you were pretty successful with it. It's definitely a difficult thing to try. So, I mean, your hardware just excellent. I'm sure we haven't covered every hardware aspect of the robot. It would be incredibly difficult to. But let's talk about your software. I think that's equally impressive in your robot. So why don't you start out with the autonomous? What sensors do you use to make sure you can localize as consistently as possible?
Yeah, so for the most part, we use drive encoders to just navigate throughout the field. But when going over the barrier poles, we noticed that the drive encoders tend to slip a little, even though we have suspension. So what we do is we actually have a system of 4 ultrasonic distance sensors. So one on each side of the robot, and then there's 2 on the front. But basically what these do is they allow us to relocalize the robot's position against the walls of the perimeter. And because they're ultrasonic, it actually works at a pretty wide variety of angles. Because they don't pass through the...
Sure. Yeah, no, that's awesome. And then what about Teleop Automations? You guys have so many Teleop Automations. I'm sure you can just control all of these servos and motors just like that with a press of the button without these automations. So how do you do those? Are there any tips you have for new teams that are looking out to automate their Teleops as much as possible?
So we do have a couple of automations in Teleop. Primarily, we have the automatic retraction, or the software-assisted automatic retraction. So although we do have coaxial gearing, sometimes the motor can stall against something that's not freight, and then what do you do? So we actually have a distance sensor inside that intake, which senses when freight has been collected, and it also doubles as a color sensor to detect what type of freight has been collected. And the automation there is that once we have transferred it and the deposit extends out, we can then change the level to which we deposit. So if we have a ball, it goes to level 2. If we have a cube, it goes to level 3. And this optimizes the space that we take up.
Yeah, I mean, we saw you guys repeatedly placing the balls only on the middle level of that Alliance hub and trying to fill up the top with all of the cubes and boxes that you could. I think this has been a really great overview of your whole robot. Ayush, the whole MSET team has really done a lot this year. You guys went on from NorCal to Worlds, and then you did really excellent at Worlds and really excellent at MTI. Just an incredible robot for the whole season. Thank you very much. Reporting for First Updates Now, I'm Abbas.
Thank you.
Discover MSOE, where hands-on learning today can lead to real-world applications tomorrow, including their We Energy STEM Center built to support FIRST teams. Head on over to msoe.edu/visit to see a virtual tour and schedule your campus visit today. Apply the skills you gained as a FIRST student or mentor and help change the world at Stryker. Stryker is the top career choice for many of those in FIRST because of their commitment to innovation and saving lives. Learn more about the incredible culture at Stryker and view their thousands of positions available around the world at careers.stryker.com. Don't forget to like, subscribe, and ring the bell to stay up to date on our new videos. Keep the conversation going and provide your input to our content. Watch our live shows at twitch.tv/firstupdatesnow. Join our Discord at discord.gg/firstupdatesnow and check out Fun FTC on Facebook, Instagram, and Twitter, and First Updates Now on Facebook, Instagram, TikTok, and Twitter.